Hi everyone, today I want to talk about the real-time communications in robotics. Actually, I'm going to explain LCM in this field. First, I want to give a little brief about how LCM invented. In the DARPA Grand Challenge, let me open. There is a challenge about the autonomous vehicles, as you guys see here, and there's many sensors on it, cameras, lidars, a lot of. And MIT University developed LCM in this period, which is useful for real-time communication. Also, this challenge is made in DARPA. Yeah, Defense and Advanced Research Projects Agency. So I just want to give a brief about that. Its mainly focus is real-time communication in robotics. I want to start with how we are using this because I think it's a really easy way to explain it. So let's start the visual environments. Okay, now we go to the terminal. I'm using the Python because it's easy to implement and I think it's easy to explain. Also, but LCM support many languages like C, C++, Go, Java, Lua, MATLAB. I don't know how does this work, but they are supporting. Let's use the Python one. Okay, let's open the VS Code in here to make code. First, we need to also I made some notes. We need to install some packages like LCM package and libLCM for the LCM structures in communication. I will explain them. Let's open one file, publisher and receiver. Also open the terminal in here. By the way, I'm using Linux because it's LCM support Linux right now. They don't have support Windows, I think, but they can do in the furthermore. But today, they're not supporting Windows. Let's install LCM package because we will use this. Also, we need to install the LCM, libLCM for the package, creating package. Let's download it too. Okay, so we are ready to go. Actually, it's very easy to set up, but we have one more thing. Your router needs to be enabled to make a UDP broadcast. It's not something about software, this is a hardware situation, so you need to find one of them, but I think most of the routers are support them, so you don't need to search anyone. Probably your router supported. We need to import LCM for usage. First, I want to explain how we can make a publisher. We will publish data over the local network. First, I will explain how we can use it in the computer. Actually, not the local network, in computer. Then I will explain how to make a multicast between devices in local network. Also, I remember we need to make a package for the transmitting package. We need to make the infrastructure of the package. Let's make it first. We need the LCM files for this. Like, let's make a car project, which we have a light on the car, and we need to control the light. Let's make a police car. So we need to control the red and blue lights. Let's give it name. Which name is good? Let's give it a LED like this. So we need to make an infrastructure in here. Lib LCM generate, and we need to find the LCM data types. Yeah, we can use these data types for making the structures. It looks like a C, but unfortunately we don't have unsigned integers. We have only signed integers. That's the problem, but the LCM is currently developing, so I think they will figure out in soon. We will create a XCLM package, so it's good to mention that in here we need to do that. After that, we need to give the specifications of the package. Let's look like an C struct. Let's make a let control struct, which we will use in the let struct. So I give the type of the field and the name of the field. So let control is the one object. You can think like this if you was worked on object-oriented program. You guys can think this is the let control object, and we will remove two objects. Let's assume that I will give the lets. In the lets, I will put the two let control. Also, I want to send the timing data. When I send the data, I will put the time in here. So let's put the time. Also, we need to add the lets. So we have a let structure which have the one time and two lets. These lets are from the let control structure. So we made the structure like this. Also, this making the where is the lets if they placed on the front of the vehicle or the back of the vehicle. Let's give the position of the lets. So nice. Let's compile this structure to Python file actually, because we need to use like this in Python. We need to convert it. In this, while doing this, we will use the LCM package, LCM generate package, which we are already downloaded in here. We will compile it for Python. Because of that, I will put the -p sign, -p. And what is the file name? It's the let.lcm. So if we execute this command, we will get a file from here, XCLM file, which have the lets and let control, and we can use this in the project right now. We will publish this data over the internet, local network for currently, but I will explain how to noticast the other devices. Let's import LCM. After that, let's import XCLM from XCLM. Sometime VS Code doesn't figure out where is the XCLM. If this happens, just close the VS Code and open again. It's fine. So let's import everything inside the LCM. This means to import everything in LCM, like this ones. We will import into the publisher file. After that, we need to create the LC object for the starting the LCM communication. For the local network, you guys can leave as like this. And let's create the message. Our message is let message, and we need to put the data in this message. This import time also. Message dot time, which we used in here. Message dot time is equal to time dot time, which I'm getting the timestamps. Message dot position is equal to, let's make it front. Message dot red light dot enabled. We use enabled in here because we use enabled in here. So and let's make blue one false. And we created the message. We need to publish it. We need to give the channel name while we are publishing. I will publish this data in the carlet control channel, and we need to put the message with encoding to with encoding like this, and it will publish the data over the internet. So nice. Let's make the publish receiver. Import same things again. I think we will use them. For the receiver side, code a little bit more long. Let's create the function handler. When the signal is came, we will execute the handler. And put the function in here. And let's create the LCM object. We will use the same one. And we need to create the subscribing. Actually, I need to rename this as a subscribe. I think this will be more meaningful. We are making subscriber right now. If we get a signal from which we mentioned in here in the carlet control, also we will write this in here because we are subscribing to this channel. If the message came from here, we will take action which we write in the handler function. So if the message comes, we will use handler function. Let's write it here. The function will execute this when the signal comes in this channel. While executing, LCM puts the channel data and data which is coming from the broadcast or broadcast in here. So let's put them to here. We will use them in the function. First, we need to decode the message in the type of let's control. We need to convert it to let's object. After decoding, we can use the data on it. For example, let's print all of the data. Okay. What we can write? We can write channel. We can write time, position, other things. We are getting from time to in the message, and what we are mentioning position. So let's write the other ones too. In the red let, we are getting the enabled status. That's why I write like this. If you write the red let, we will. It means the printing this object, but we want to print in the field in this object. So nice. Let's start this and look how it works. Also, if you want to make it in the forever, you can make it in the while loop like this, and let's make the K port interrupting for closing the file. So nice. Let's start it. We start the receiver. Let's start the transmitter. Actually, subscriber and publisher. I'm speaking with Arif. So as you can see, if we publish the data, it came through here. Let's publish the data with the timings. I will use here. Let's publish data in 100 milliseconds interval. As you can see in the right, it's published data exactly in the 100 milliseconds, and this is really good in your real-time project. And that's what I'm talking about. Let's publish it. Also, we can check the time delays between the package. Let's make the we can measure it. It's in seconds, but we want to need it in milliseconds, so let's convert it. And we need to save the delay for the next package calculation. Yes. This guys is the 100 milliseconds in every package. Let's make it 50 milliseconds. Let's make it 10 milliseconds. Every 10 milliseconds it sends signal to the controller. So control, yeah, control. It's controlling the LEDs on it. Yeah, we can also change the LEDs. Let's make it to if the mode of I is if the mode of I with 2 is 0, make it true, else make it false. Let's make it for 3. Also, we need to increase the I for the change. As you can see, it's changing. Yeah, but the things in here is going, it's happening in our computer, not in the network. So make it in the network, and I want to give one example of it to make it more concrete. So let's go to the multicast part, which is actually useful. And that's why I'm using the LCM. Almost same, but we need to make some change in our network. I noticed in here. We need to use UDP protocol for using this. UDP means messaging, and for the multicast. As you guys see, we are creating LCM we need to give an multicast options in here. First, if you are using the Linux, make your firewalls off, because it can prevent the publish message or receive message. You can make this like this: sudo UFV disable. After making this, please restart your computers. After, you can continue and make sure devices are connected in the same network. We need to select an IP for this communication. You guys can select IP between this interval. I will use the, let's put it in always in top. Let's identify the protocol UDP multicast and IP which we are broadcasting. This is for administratively, we will use in the local network. This is for your local computer, not in the network. And this is for the communication between the world, like internet. Don't use two of them if you are making in the local network. Use this. For the port side, you guys can use which port is available in your computer. I will use this one. And we need to clarify the TTL. Which one? I will explain how logic go in here. And we can put this in here. This is your computer. This is your router. And this is your vehicle. Let's think this is the Raspberry Pi. This is the computer. And you are publishing the message with TTL1. If it's go to the router, it's state TTL1. But when the router publishes this message to the vehicle, it makes the TTL0. And the message broadcast stops here. The message don't go in anywhere from here like this, because the TTL0. TTL means that the count of the hopping. How can I explain? Counter of transmitting. Actually, I can say. If you guys make the TTL3, when it's going to reflect to your computer actually, because if you make 3, it's going to be 2 in here, 1 in here, and 1 in here actually, and it goes to here and echo your computer. We don't want it, because of that we are using TTL1. If you use this message in your local computer, make it TTL0, which means it can go to the here, because the hopping count is done. So I think I was able to explain a bit. We are using TTL1. In the subscriber side, we will put the same thing. Where is it? We are okay here. We use the same thing. Now we can, if we put the same code in the other device, we can use the communication. Let's I said I put one Raspberry Pi. Let's connect it. I put one Raspberry Pi in the starting of the video. Let's connect it via SSH. Let's create the same virtual environment. Okay. And let's connect to the Raspberry Pi with SVTP. So, okay, our project folder is here. Let's put the same codes in here, not VNV, the other ones. Let's put them. Okay, let's start the receiver here. Receiver subscriber. And let's publish the data. As you guys see, we put the delay in 10 milliseconds, but it's changing while sending. Okay, let's stop it. 10, 9, 13, 6, 8. It's changing, but it's not too much because in the real times, by the way, both devices are connected in the Wi-Fi right now, not Ethernet. For the Wi-Fi, 2 milliseconds, I think not very important. But in the Ethernet, it's worked more accurately. But for the Wi-Fi, this is really good performance. Let's make it 5. I didn't try it, but let's try it. Yeah, 14, 4, 5, 4, 5. Actually, not bad. It's very good. It's very enough for the real time. Okay, for the practical part, let's open the LED and close the LED with using the GPIOs on the Raspberry Pi. Let's install the GPIO package for the controller. This won't work in the local computer because it's not Raspberry Pi, but we can write the code. It makes the writing code easier. Let's import the library for the using. And we need to set the mode of the GPIOs. GPIO VCM, what is this? So this is about your Raspberry Pi's specifications. If you are using 3V plus 2, or if you are not using Raspberry Pi 1, use VGM. It's mentioning the GPIO modes actually. Then let's set the GPIO for the use to LED. Let's make which I am using. I am using the GPIO 27. So let's make it the out. How we can find the GPIO output? We can use the schema of the GPIO. For example, I will use 27. Just write 27. The GPIO 27 means 27. Just use it. We'll give digital high and digital low because of that I set up to out. Then let's use it in the code. If the red light switch to true, we will make it enabled. Otherwise, we will. If the red light switch to true, let's open the LED. If it's not, make it close. And 7. You guys can mention in the here actually. Okay, doesn't matter. Let's write like this. So we are changing the output of the GPIO with using the message. Okay, nice. So let me open the camera and show it. Okay, now I'm started recording. Let's put these files to the Raspberry Pi. Actually, we need to just put the subscriber because we only changed this. Let's install Raspberry Pi GPIO package to the Raspberry Pi because I forgot. Okay, we need to put install also. Let's activate the source. Okay, let's start the code. It's not making anything because I don't start the publisher. As you guys see, it's too fast. Let's increase the delay. Let's make it 300 milliseconds. And we can control that with using LCM. You guys can control other things like motor or anything you want, or you can send the camera data with using the dimensional data. Like you guys can make Teaser 16 image. Like if you have a image type 200 pixel and it's RGB, you guys can make a image structure like this. Thank you for listening to me. Also, I want to mention one more thing. These packages are not encrypted messages. If you are transmitting some critical data, let me show it. Let's open the Wireshark forkit, and I'm close the camera of Raspberry Pi. So let's start with using the sudo. Okay. We will use the IP destination, which is this because we are publishing data to here. And I select my Wi-Fi chip because I'm publishing data with using the Wi-Fi. As you guys see, what can I show? Let's write in here. I will give a break in here, and I just want to look to encoded message. Yeah, this one. Let's scroll to the last message, which is this one, and we can find our message in here. Let's look to the table. As you guys see, this is front, and we have also sent the front in here. Like it means it's not encrypted. Also, you guys can find the other bytes in here without encryption. So this means this is not secure if you are sending the critical data. But if you are sending the data about camera or your robotics. I think it's not problem. This situation has some positive and negative outputs. Positive, your communication very fast because you don't need to consider encryption and decryption times. The negative part is security, and be careful about them. I just want to mention you guys can encrypt data while transmitting, because this is publishing this encoded message, and here is the byte type. You can encrypt these bytes and decrypt these bytes. In here, actually, the data is also the bytes. You can encrypt and decrypt them while using the program. The encryption and decryption is your part. In the ROS and ROS2, these parts are automatically, but they are not real-time communications. But they are not real-time communications. So that's all. Thanks for listening to me. If you guys have any questions, you guys can mention on the comments. I will be glad if I help. Have a nice day.